This example is going to show us how Newton's method can sometimes fail to zoom in on the zero of a function. So remind ourselves of what Newton's method is. It's a way to estimate the zeros of a function by taking an initial guess, we'll say xn, subtracting the function value at xn divided by the derivative at xn, and this is how we get our next value, xn plus 1. And we can do this over and over again, and these x values should generate a sequence that zoom in on the zero. But sometimes this doesn't work. And here is a counterexample, f of x. If we defined f of x as a piecewise function, which effectively kind of looks like this cubed root character when x is equal to 2. It has some sort of shape that resembles that. We're going to show that Newton's method does not zoom in on that 0 right there when we have an initial guess of 3. We're going to show that it actually bounces back and forth between two values, and it never actually zooms in on the 0. So our initial guess is 3. Now our next guess will be 3 minus the function at 3 divided by the derivative at 3. Now, because our function is defined piecewise, we should be looking at this bottom function because x is greater than or equal to 3 here, or sorry, greater than or equal to 2 when x is equal to 3. So here, our derivative will be, or rather, let's just write down our function. It is x minus 2 to the 1/2. So our derivative is 1/2 x minus 2 to the minus 1/2. So our first guess, our x1, the next term in the sequence will be 3 minus f at 3. If you plug 3 in here, you get a 1. And our derivative at 3, if you plug 3 in here, you get a 1/2. So this becomes 3 minus a 2 or a 1. So the next term in the sequence is a 1. All right, so let's go through the process again. x2 will be given by x1 minus the function at x1 divided by the derivative at x1. So because we're plugging 1 into the function, we should listen to the top definition of the piecewise. Right? When x is equal to 1, it's less than or equal to 2, sorry, less than 2. So we look at this function. So here, the function is minus 2 minus x to the 1/2. And our derivative is then minus 1/2, 2 minus x to the minus 1/2, but then times a minus 1 by the chaining rule. So we just have a positive 1/2 out front. So x2 will be given by 1 minus f at 1 over f prime at 1. This is 1 minus, for f of 1, if you plug 1 into this function, you get a minus 1. And for our derivative at 1, if you plug 1 into this derivative, you have a 1/2. So this becomes a 1 plus a 2 or 3. Okay, so our first guess was 3, which gave us our next guess of 1. But then that guess of 1 gave us 3. And that kind of just puts us back in that first position, right? When we go through this process again, it's just going to send us to 1. And 1 just sends us back to 3. So this sequence of x values just bounces back and forth between 3 and 1, 3 and 1, 3 and 1. It never actually locates that 0 right there. So Newton's method will not always work. Most of the time it does under suitable conditions, but there are cases where it does not converge.